Welcome back, everybody. Moving on to another question that is dealing with odd and even functions. We have to determine algebraically if the polynomial function f of x equals x to the power 4 plus 2x plus 3 is an even function. Now, algebraically, an even function, what that means is that f of negative x is going to equal f of x. If you remember from the lectures on even and odd functions, this basically means that the function is symmetrical about the y-axis. So, f of x, the right side of this equation that we are trying to prove, well, that's already given. That's x to the power 4 plus 2x plus 3. What about f of negative x? What's that going to be? Well, we just plug in negative x for all of the x values in the function that we are given. So negative x to the power 4 plus 2 times negative x plus 3. And notice how this negative x to the power 4, that would just give us x to the 4, right? Because there's like this negative 1 in front of the x that we're taking to the power 4. So then everything inside gets taken to the power 4, and the negative 1 to the power 4 is just positive 1. So we're just left with x to the 4 here. Positive 2 times negative x gives us negative 2x, and then this positive 3 just stays the same. And notice how this, which is f of negative x, does not equal this function, f of x. So this doesn't hold. And they're asking, is the function even? So the function is not even. That is your answer. So basically, whenever they're asking whether a function is even algebraically, you got to prove this here. If they were asking whether a function was odd, and you have to prove it algebraically, if you remember, we have to prove f of negative x equals negative f of x. But they aren't asking us that in this question. They're asking us if it's an even function, so we have to prove that. Both of those don't equal, so the function is not even.